In this video, we're going to go over how to find the integral and radius of convergence for a power series. The first thing we do when we're looking for the integral and radius of convergence is we want to use the ratio test. So the ratio test is when we take the limit as n approaches infinity, the absolute value of a sub n plus 1 over a sub n. So let's apply this to our series. So we're going to take the limit as n approaches infinity, the absolute value 2 to the n plus 1, because we're taking our a sub n, which is this right here, and we're going to apply plus 1 wherever there's an n. So it's going to be 2 to the n plus 1, x to the n plus 1, times n plus 1 plus 1, divided by n plus 1 plus 2. So now this is our a sub n plus 1. That's what we just found. So now what we gotta do is we have to find the a sub n. So our a sub n is going to be taking the reciprocal. So it's going to be n plus 2 over 2 to the n, x to the n plus 1. So we're going to take a limit as n approaches infinity. So with the 2 here, we have 2 to the n plus 1. So next what we're going to do is we're going to simplify this a little. The 2 to the n's are going to cancel. So we're just going to be left with a 2 on the top. Next, we have our x to the n plus 1. We have our x to the n, so those are going to cancel. So we're just going to have 2x, and then we're going to have n plus 2 times n plus 2. And on the bottom, we're going to have n plus 3 times n plus 1. So we still have the limit as n approaches infinity, the absolute value, 2x times n squared plus 4n plus 4, all over n squared plus 4n plus 3. This is a little easier to look at and figure out how we would take the limit of this. So since both of these n's have the same power, we know that they're going to be growing at the same rate. So that means that our limit is going to end up being 1. So we're going to have the absolute value of 2x times 1. And this is just going to equal the absolute value of 2x. So now for the next part of this video, we're going to figure out what the radius and integral of convergence are. So the ratio test gave us the absolute value of 2x. So for the ratio test, the series converges for all values less than 1. So we want to find when it converges. So we're going to set this to be less than 1. And let's break it apart and solve for x. So when we have absolute values, we're always going to take this value, and we're just going to make that negative 2x, whatever's on the inside. So then we divide by 2, we get negative 1/2 less than x, less than 1/2. Alright, so this tells us our radius of convergence is going to be 1/2. Because if you were to look at this on a number line, you're going to have 0, negative 1/2, 1/2. Each one of these is a distance 1/2 from the center. And for the last part of this video, we're going to test the endpoints. So we found our integral of convergence. It doesn't actually tell us if these are included or not, right? So what we got to do is we have to go back, and we're going to plug in when x equals negative 1/2 and when x equals 1/2 into our original series. Alright, so x equals 1/2. So we're going to plug that in. We're going to have the series n equals 1 to infinity, 2n, and instead of our x, we're going to put 1/2 to the n times n plus 1. It's all going to be divided by n plus 2. So if we simplify this, we're going to get the series as n goes from 1 to infinity, with n plus 1 over n plus 2. So if we were to take the limit of this, we would get 1. So by divergence test, the series is going to diverge. Alright, so now we know that when x equals 1/2, it's not included. Next, what we're going to do is we're going to check when x equals negative 1/2. So we're going to have the series n equals 1 to infinity, 2 to the n, and then instead of x, we're putting that negative 1/2 in to the n, times n plus 1. It's all going to be over n plus 2. And let's simplify this down. So we're going to have the series, so n equals 1 to infinity, 2 to the n, negative 1/2 n plus 1. And then this right here, we can simplify this part to be, instead of writing negative 1/2 to the n, we can write 2 to the n times negative 1 to the n times n plus 1, and then that 2 we can put on the bottom to be 2 again. N plus 2. Right, so we distributed this power of n into here and got the negative 1 to the n and then the 2 to the n. So then we simplify this again, and these are going to multiply to give us 1. So we're going to have the series, infinity, n equals 1, negative 1 to the n plus 1, n plus 2. So this limit, if we were to take the limit of this, would just be oscillating, right? Because we have this negative 1 to the n, so it's going back and forth, back and forth. So it's not going to equal 0, which means that the divergence test is not inconclusive. Therefore, the series diverges by divergence test. So this means when x equals 1/2 and when x equals negative 1/2, neither of those are going to end up converging. So our interval of convergence is then going to be negative 1/2 less than x less than 1/2. Now, if let's say at negative 1/2 it did converge, then instead of writing less than, we write less than or equal to. But since they both diverge, we're just going to leave them like this. Now, it would be the same if you wrote them like this, right? Those are equivalent statements. And then finally, our radius of convergence was 1/2. Thank you for watching.